Okay, so we're going to do more exercises on differential equations. Suppose an experimental population of fruit flies increases according to the law of exponential growth. There were 100 flies after the second day of the experiment and 300 flies after the fourth day. Approximately how many flies were in the original population? So you have that same formula, y equals c to the ekt, okay? So what it's saying is that after the second day, there were 100 flies, okay? So 100 equals c to the ekt. And after the fourth day, you had 300 flies. So c, e, k, t. So you have the first equation here, and you have the second equation here. There's just a system of equations, right? So what we're going to do is to find this c, okay? What is this c here? Well, it turns out that c is going to be equal to 100 times e to the minus kt, all right? And we're going to substitute this into the second equation. So that means 300 equals 100 e to the minus kt. Well, actually, hold on. In here, it's the second day. So this is going to be 2. Yeah, I'm going to have to erase a bunch of things in here. Here. Erase over here. Kind of like that. Okay, so this is going to be after the second day. And this is going to be at the fourth day. Alright, so e to the minus 2k times e to the 4k is going to be e to the 2k. And then you have 300 divided by 100, right? So what is this going to be? It's going to be ln of 3 divided by 2 equals k, which is approximately 0.5493. Okay. Approximately how many flies were in the original population? So this thing in here is going to be y equals, yeah, there's something else too. You found the original population is when this is 0, okay? So this term in here becomes a 1, not this term, but this part of the equation becomes a 1. And then you have the c, okay? When you want to find out the value of c. But you do have the value of k now. So you can substitute this thing in here, all right? It's going to be, c is going to be equal to 100 times e to the minus 2 times, I'm just going to do a point here, 0.5493. Yeah. Okay. And this is going to be approximately 33. So there were 33 flies on the first day, right? And then you have 100 flies on the second day and 300 flies on the fourth day. So the number of flies are increasing, right? 33 and then 100 and then 300. So if it's increasing, it's because k is positive, and it is positive. See? Okay. Now let's do another exercise. 4 months after it stops advertising, a manufacturing company notices that its sales have dropped from 100,000 units per month to 80,000 units per month. If the sales follow an exponential pattern of decline, what will they be, the sales, right? What will they be after another 2 months? So you see, sales have dropped from 100 units per month. So the initial value is 100. So we know that y equals 100,000, right? 100,000. E Do we have the K? No, we have the, okay, it's going to be 100 KT. Okay, so we have that. Now, it also says that 4 months after it stops, it drops from 100,000 units per month to 80,000 units per month. So we know that 80,000 equals 100,000 e to the K4, okay? And when you, of course, dividing, you're gonna get 0.8 equals e to the 4k's, the same stuff. So ln of 0.8 divided by 4 equals k. That's what it means. All right? Because you're going to take the ln on both sides, so it's going to be ln of 0.8 equals 4k, k equals ln of 0.8 divided by 4, which is approximately minus 0.0558. Yeah. So you see that k is negative, that means it's declining, and it is declining. So in the first, at the 0 month, when t is equal to 0, you had 100,000 units per month, and after 4 months, you had 80,000 units per month. So it is declining. So after another 2 months, that means after the 6th month, okay, so you have y equals 100,000, okay, times e to the minus 0.0558 times 6, because we're talking about the 6th month, right? So at the 6th month, what is it going to be? So you do like minus 0.0558 times 6, and you elevate e to this power and you multiply to 100,000. So this is going to be approximately 71,500 units per month. Okay, so first you had 100, after 4 months you had 80, and after 6 months you have this. So you know that it's declining. And there's a, okay. Let's see here. Let me think. Okay. I'm thinking. Let me think. I'm thinking, guys. Hold on, just go have some coffee. I'm thinking about this stuff in here, if I show this now or later. Okay, I'm going to show this now. It says in here, let y represent the temperature in Fahrenheit of an object in a room whose temperature is kept at a constant 60 degrees. So the temperature in the room is a constant 60 degrees. If the object cools from 100 degrees to 90 degrees in 10 minutes, how much longer will it take for its temperature to decrease to 80 degrees, right? So the thing here, well, right now I'm not going to use this formula. I'm going to say that the difference in temperature, this is going to be according to time, okay? So y is going to be the temperature, and dy dt is going to be the rate of change in temperature according to time, in minutes. So you see, it's going to be like k times y minus 60. Why? Because this is according to Newton's law of difference in temperature, okay? If y is at 60, then y is not going to change because the room is at 60. So if you have a coffee, is that what it is in here? No, it's just an object in a room. So if the object is at 60 degrees in a room that's 60 degrees, is there going to be a change in temperature any longer? No, it's not, okay? And there's something else too. Let's just say that y is greater than oh, okay, well, let me hold on. If y is greater than 60, let's just say that y is 70 degrees, then this thing here is going to be positive. But the temperature of the whole stuff is decreasing. So if this term is positive, the k has to be negative. And if the k is negative, the whole thing is going to decrease. Okay? Now let's just say that the object is at 40 degrees. If the room is at 60 degrees, the object has to heat up. So this thing in here now is going to be negative. Okay? So, well, yeah, it's going to be negative, and this has to be negative too. Oh, that's weird. Yeah. Okay, never mind then. Never mind. Okay, so let's just do this. And of course, right? So you see what we can do here is like, this is like dy dt. All right? Dy dt equals, let's just multiply it out, ky minus 60k, or one thing that I can do, one thing that I can do is to not multiply it out, because this is not going to be a, okay. I want the y on the left and I want the t on the right, okay? So what I'm going to do is say that I'm going to put it over here. I'm going to do this slowly so it doesn't get confusing. I'm going to divide this thing here, so it's going to be y minus 60, all right, on the left side. And here you're going to have a k. This dt is going to come over here, so I'm going to put the dt here. I'm going to erase this stuff. And now you have y on the left side and t on the right side. And all you got to do is integrate both sides. Okay? So this is being elevated to 1, so you know what this is going to be. It'll be the ln of y minus 60, all right, equals kt. Now, what does this mean? All right? It means that E elevated to KT equals Y minus 60. Let me think. Oh yeah, there's something else too that I want to show this to you guys. Remember that when you integrate like this on both sides, you gotta do like plus C. We're just gonna call this C1. Okay. So what do we have in here? E elevated to KT plus C1, right, is going to be equal to y minus 60. But I'm just going to put the 60 on the other side already. So I'm going to erase this in here. And I'm going to say plus 60. All right. Now there's something else here. E to the KT plus C1 is the same as E to the KT times E to the C1. Now this is a constant and C1 is also a constant. So I'm just going to say this whole thing is C, all right? So y equals C, right? Because it's multiplying C to the KT plus 60. And there's something else too. When you did the ln, you had to put this in absolute value, but you don't have to worry about that because y is 100 degrees, then it'll drop to 90, then it'll drop to 80. So y minus 60 is always going to be positive in here, so you don't have to worry about the absolute value. So you have this stuff. Now, there's something else too that you know. At t equals 0, which is the beginning, the whole thing was at 100 degrees, okay? The object was at 100 degrees. So we know that c has to be 40. Why? Because this is e to the kt, so t is going to be 0. That means that this is 1. So, and this is 100, okay? So 100 minus 60, c is equal to 40. So what I'm going to do is to drop this c in here. I'm going to put a 40 in its place. There. Okay. Now, there's something else that we know. All right. Something else that we know. We know this. So it's y is equal to 40e to the kt plus 60. It says here that the object cools from 100 degrees to 90 degrees in 10 minutes. So keep going, all right? So in 10 minutes, it was 90 degrees. So 90 here minus 60, that'll be 30. So it's 30 divided by 40, right? It's going to be 0.75. So let's just put 0.75, man. 0.75 equals e to the k times 10. I'm going to put 10k. All right. So the ln of 0.75 divided by 10 equals k, which is approximately, let me see here, let me think, minus 0.0, these numbers are big, 2877. Okay, so the whole thing is going to be y equals 40 times e. Now we know k, right? It's minus 0.02877 t plus 60. All right, this is the formula. So it's asking when y is equal to 80, how much longer will it get? Okay, how much longer will it take? So if this is 80, 80 minus 6 is 20. 20 divided by 40 is half. It would be half e to the minus 0.02877 t. Okay, taking the ln on both sides, ln of half equals this. All right, so it's going to be divided by minus 0.02877. T is equal to this, which is approximately 24.09. Okay, so it's asking how much longer. Well, it's going to be 14.09 minutes, right? Because 10 minutes had already elapsed. Another 14.09 minutes, and you're going to have the object at 80 degrees. I think that, yeah, that'll be it, guys, because we're going to go to separation of variables on the next video.